Welcome to DQRB Analyzer and DQ Rulebook's Data Bureau service. Data quality rules are essential for any business because they demonstrate whether your data is of a high enough quality to be fit for purpose. We can apply these rules to your data at varying levels of sophistication. The rules we create can be mapped to rule groups representing either regulatory data quality dimensions such as completeness, appropriateness, or accuracy, or to the dimensions of a think tank such as the EDM Council or JWG. Of course, if you have your own data quality dimensions, then we can map to those instead of or as well as the standard ones we use. The rules we apply are split into three categories: basic, intermediate, and advanced. First, we're going to apply a basic rule, which is that address line 2 is mandatory. We go to create a new column and use the isNotEmpty function to check that the field is populated. This will return true, which denotes a pass, or false, which denotes a fail. This then appears as a new column with passes and fails against the individual rows. This is known as a quality rule. The alternative way of creating rules in DQRB Analyzer is to create them as validation rules. Instead of seeing which individual rows pass and fail, this instead gives you a score for the rule. Any rule that ends with a true or a false can be created as a validation rule. After the creation of validation rules, the table must be validated to get a score. The scores are expressed as a percentage, the percentage of rows that passed. Next, we're going to have a look at an intermediate rule. There are different criteria that determine whether a rule is basic, intermediate, or advanced. The aspect of this rule that makes it intermediate is that it makes use of the more complex decision function. The rule we're going to create will check whether the date of birth is in a valid range for a living person. By using the current date function, we can check that the date of birth is less than the date now, i.e. it's in the past, but this could also be done with a basic rule without a decision. The decision means that we can also check that it's not so far in the past it's too old to be a living person. We're going to use a date to ensure the client is not more than 120 years old. The output of the decision will either be true or false, and then this feeds into a function that checks whether the output was true or not. Without this function, the output would just be the word true or false. With it, the output becomes what DQRB Analyzer recognizes as true or false, meaning that it shows as a pass or a fail. Because it ends in either true or false, we can then save this as a validation rule. This means that we can create custom complex rules and still see an overall score for them instead of just the individual pass or fails. Next, we're creating an advanced rule. Again, there are different criteria that can make a rule advanced, and in this case it's the application of the rule through the context of a filter, i.e. only applying the rule to certain rows. First we need to create the filter. In this case, we only want to apply the rule to clients from Bristol, so we filter the data on the city column to keep only Bristol. This is then saved as a table filter. Once saved, we can remove it. We now go to the validation rules for our table and create a new rule. This rule is going to check that Bristol clients have a Bristol postcode. To do this, we're going to use the starts with function, which, as the name suggests, checks that one value starts with another. We're checking that for Bristol clients, their postcode value starts with BS. The ability to apply rules through filters is important, as you do not always want the same rule applied to every row. The next thing to look at is rule groups. As the name suggests, these are groups into which we can categorize the rules we create. The three rule groups we're going to create are completeness, appropriateness, and accuracy. These are three widely recognized dimensions of data quality. Once they've been created, we can add the rules we apply to tables to one of these groups. This then helps the scoring to reflect which aspects of data quality the data does or does not perform well in, but which rules go in which groups. The first rule we're going to add is that the house name or number is mandatory. This doesn't check whether the value in there is a house name or number, or that it's the right one for that client. It simply checks there is a value in there, so this will go into the rule group completeness. The next rule is that the date of birth actually is a valid date. This is a column that should have a particular format, so although it doesn't check whether the date of birth is accurate for the client, it checks whether it is actually suitable to be in that column, so this will be assigned to the rule group appropriateness. Lastly, we're going to recreate the rule that checks clients in Bristol have a Bristol postcode. This is going to go into the rule group accuracy. It does more than just check whether the value is a postcode, it checks the value is a postcode applicable to a particular customer. Whilst it does not mean the postcode is definitely accurate, it is accuracy that the rule is checking. Once all the rules have been applied, we can have a look at the data quality report for the table. How well the table performed is represented by the dashboard seen on screen. Information is shown about the number of rows considered by the rule, the number that passed, the number that failed, and the percentage that passed. It also documents whether a filter was applied, which function was used, and what ranges were specified. There is a dashboard for the table overall, which shows how many rows passed every rule, a dashboard for each rule group, and then one for each individual rule. This is useful because it allows you to see the quality of the table overall, then see which areas the table does or does not perform well in, then individually see how many rows passed or failed each rule. The dashboards are currently set to display a red fail if 0% of rows pass, a green pass if 100% of rows pass, and an amber OK for everything in between. In real world terms, anything between 0 and 100% is not OK. We want to fail anything that doesn't have a very high pass rate, so we're going to move the fail threshold up to 94%. These thresholds can be set to whatever the client specifies. To demonstrate the way that DQRB Analyzer scores, we're going to add in a rule to the table that we know not all of the rows will pass. To do this, we're creating an expression to check that all of the postcodes are valid UK postcodes. We apply it, revalidate the table, and check the report again. The dashboard representing the overall score for the table is quite low now, as very few rows have passed every rule. The data is scored differently in each rule group. The data is scored highly in accuracy and completeness, but very low in terms of appropriateness. These rule groups are really useful, as with only the overall score, it's impossible to know what needs improving within the data. Money could be wasted on data initiatives aimed at improving the completeness or accuracy of the data, when in fact it's the appropriateness that needs improving. Another way of influencing the score is to add measures. A measure changes the impact that a row failing or passing a rule has on the score. A measure will normally be applied to a column containing a financial value. The higher the value in the measure column, the more impact that row will have. By setting the measure to be the balance column, we are saying that the more money a client has in their account, the more impact their row passing or failing a rule will have. Before the measure was applied, 12.54% of rows have passed every rule. Once we refresh the quality report, the score drops to 12.16%. This indicates that some of the records that failed had quite high balances. The ability to apply a measure means the financial worth of the rows are included when working out the score, helping us to better gauge the real-world quality of the table. Using the custom functions in DQRB Analyzer, we can create and apply rules for any situation. We can use them to answer any question you may have about your data and assess every aspect of its quality. This is the first step towards having cleaner, better, and more useful data. We can keep a record of the rules a client chooses to have applied to their data so that it can then be sent to us regularly for quality checks and have the same rules applied. This ensures that the data remains of a consistently high quality.